Okay, we're carrying on with the electricity thingy bobby, right? So you've got a diagram of an electric circuit, component X and lamp, component X and lamp. So what do we know about, what do we know about this? There's two of them. Remember we said a cell is single. Yeah. It's good to know this for electrolysis anyway in chemistry. So plus minus. If you've got more than one, it becomes a battery. Right. Remember what we said? This is my own circuit, right? We know electrons are negative. So we know electron flow is that way. But conventional flow is that way. That's why you have here, let me get that. That's why you get here the arrow going that way. Right. We know that this here is a filament lamp. We know that this here is a resistor. We know this here is a variable resistor. We know this here is a thermistor. What else do we need to know? Right, okay, we know, no, okay, we know that that's a filament, that we've got it up there. Don't know why I did that. We know, what else do we know? Don't know anything else. Right, okay, yes, this. Let me do it that way. That is a diode, allows current only to flow in one direction. So let me draw that again. That's your triangle. That's a line that way. What else is there? Right, okay. Light dependent resistor. So the arrows are coming in, and light emitting diode. Oh, right, okay, no, that'll be a circle. Let me go to the top. Right, okay. Light dependent resistor, we've got that. Light emitting diode. Oh, we've not got it. You've got a fuse, ammeter, cell, battery, switch. Light dependent resistor, no. It just says diode, no light emitting. Right, okay, so we don't have to know that. That's even, I don't know if it's better, but okay. Let me turn that into a fuse then. So a fuse has got a wire going through it. That is your fuse. Wow, okay. There's a lot to learn, but we can do it. Right. Add another component to the diagram to measure the voltage. So what you do is, if you want to measure the voltage, you always put it across in parallel. I could have put it down here as well, but I've not got room. I could have put it there. Nope. There you go. That's going to measure the voltage across there. Give the name of component. So have you noticed the arrows are coming in? So it depends on light. So it's a light dependent resistor. Light dependent resistor. Okay. That's cool. Let's look at the next one. Right. Let me just look this up. Okay, that's fine. We can crack on with this. So you've got a component X. As light intensity increases, the resistance decreases. Right. Use the graph to determine the resistance of component X when the light intensity is 4. So you get a ruler, you draw a line up to the graph, and then you read across. And it's easy but not easy at the same time. It's easy to make mistakes. So we know that's 500. So 1,500, 1,600, 1,700. Okay, 1,700 arbitrary, 1,700 ohms. They've already given that here. There. Okay. The current in the circuit is 0.0018 amps. Calculate the voltage. So we're going to go over here. We're going to write down voltage equals IR. Yeah. They've given, we need to calculate the voltage. So we know the current is 0.0018. We're going to multiply it by the resistance of 4. So we worked that out. That was that there. Okay. So we worked out the resistance from that graph. And it's 3.06. Try not to round that off unnecessarily. Okay, try not to round it off to 3, because sometimes they don't give you the mark. This is physics is strange compared to the other ones, so be careful with that. Right, explain what happens when the brightness of the lamp is covered with a dark sheet of paper. What happens to the brightness of the lamp? Right, okay, so if you cover it, there's no light coming in. There's no light coming in, so the light intensity is down here, right? So very little stroke, no light's getting in, so the resistance will increase. If the resistance increases, the current will drop because the voltage stays the same. So no light, so we know resistance increases from the graph. Resistance increases. So current decreases. What you have is this, look, V equals IR. The voltage is going to stay the same. So if this goes up, this has to go down, because you're multiplying them. That's one way of looking at it. So for example, if I said to you voltage is 100, and if I said to you current is 20, resistance is 5. Now on the next one, if my resistance has gone up to just say 50, the voltage stays the same, so it'll be 50 times something, 2. So now as the current goes down, the brightness of the lamp goes down. So we can say brightness of lamp decreases or goes down. Done. That makes sense. Right. Okay. Question 10. Oh, we're only looking at part B. Part A must have been something else. Or it's to do with magnetic fields, but we weren't interested in that. So it's to do with, it's a speaker question. Right. They're connected in series. That means that they are next to each other like this. If they were in parallel, they would have been like this. Something like this, but they're not. So we're not interested in that. The variable resistor is set at 5. So they've given us that. They've given us the voltage. They've given us the current. The total voltage across the two is 0.75. So they've said that the voltage across here, right? If I put a V there for voltmeter, it's 0.75 volts. Show that the total power of the two loudspeakers is about 0.1. So they've given you the formula power. So they've said power equals IV, current times voltage. I remember it as PIV. They've said that the voltage is that and the current is that, and it's a 2 marker, so it's simply 0.15 times 0.75 is 0.1125, which is about 0. Yep, done. Okay, what else is there? Ooh, right. So what I'm going to do is I'm going to just do this. Put it down here. Go move that across so then I can see. Whoa, that was a bit crazy. Right, there you go. So we need to plot this. Right. I'm gonna pretend I've got a straight line ruler. I'm gonna plot resistance of variable. I'm not going to be lazy. I'll try not to be lazy anyway. Resistor. And I'm going to put in brackets the units. And then I'm going to draw a line up here. Straight line as I can. There you go. And I'm going to put power of loud speakers. And I'm going to put the units in brackets. Now, that's the easy bit. The hard bit is trying to scale it up. So what I'll do is I'll change color. So I've got 1, 2, 3, 4, 5, 6, 7. I've got 15, right? 7. Are they going up in? Yeah, nice numbers. So I could put that there as that is 0. 0. Whoa, take it easy. 2.5, 5.0, 7.5, 10, 12.5, and 15. Okay, 1, 2, 3, 4. No, that's fine. That'll do. Happy with that. Right, now we've got 113 here. So I'm going to read that as 113. So it's going to go from 0 to 113. So if I did 10, 20, 30, 40, 50, 60, 70, 90, 100, 110, 120. Okay. So I can do this, right? I can do 0.1, 0.2, 0.3. It's a bit painful this, but it's got to be done. 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. No, I am lying. It is. Oh, right. All up. Oh, 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 oh. Can I get away with that? Yes, I can. 0.01, 0.02. Oh. Yep. Right, okay. Let's do it this way to avoid confusion, he says, after making all those mistakes. Right, let's keep going. So I'm going to read this as 60. I'm going to read this as 70. Read that as 80. Read that as 90. Read that as 100. And read that as 0.110 and 120. That's how I'm reading it. It just makes it easier. Right, so we've got a maximum of 113. So we've covered that scale. So now that was the easy bit, I think. So let's get a different color. What color would stand out? Blue. Right, we know 0, 0 is there. At 2.5, I'm doing 100. At 2.5, I'm doing 100. At 5, I'm doing 113, 110, 11, 110, 11, 12, 13. It's about there. Okay, 7.5, 1.08, 1.08. 1.08, 1.08 would be there. And now at 10, I've got 1 at 10, and then at 12, 92, 12.5, 92, 80, 92 is there, and 15 is 0.085, 0.085. Right, there you go, done. Draw a curve of best fit. Right, that'll be an interesting one. Third point. Yep, so what we can do is, this is going to be tricky. So if we did something right, and then I think it'd be right. I'm not convinced that so what I'm going to do is get rid of that because it's a single curve. Did it say single? It just says draw curve. So look, the curve is doing, oh, where are we? Why aren't you working? Let's try you. No, let's try you. The curve is doing something like this. Now, curve of best fit, there you go, because that, yeah, you could do. Right, single curve with a peak within one large square of the third point. Yep. Yeah, and then you can do, yeah, I suppose you could do that. Right, okay, I'm not too sure on that one. We'll have to ask somewhere. Right, okay.